And I want to talk through how we would solve this. How do you find the volume of a rectangular prism, a box? Length times width times height, yes. So volume is equal to length times width times height. So what is the length of this box? Let me zoom out again. What is our length? What'd you say? 8x minus 3. So here's my length. Eight x minus 3. We're going to multiply that by our width. What's our width? Yes. 3x plus 4. And then we're going to multiply that by the height. What is the height? X. How many things can I multiply together at a time? Just 2. So let's focus on these 2 right here. We're going to multiply those 2 together, and then we'll multiply that result by the x at the end. So I have this right here. And then I have 3x plus 4. Need to use the distributive property. So I do 8x times 3x. What does that give me when I multiply those 2 together? Yes, ma'am. It's going to come out to be a long polynomial. I think it actually has 4 parts when we're all done. It might only have 3. I'm not sure off the top of my head until we get to the end. All right, 8 times 3? 24. So this is going to be 24 what? X squared. And then I have to distribute here. What is 8 times 4? 32. So plus just 32? 32x. Then I have to take my negative 3 and distribute that as well. What is negative 3 times 3x? Negative 9x. And negative 3 times 4? Negative 12. Perfect. All right, so there's that. I'm going to bring this piece down so that I don't forget about it. Do I have any like terms here in the middle in black that I can combine together? 32x and negative 9x. What do I get when I combine those 2 together? 23x. So I have 24x squared plus 23x minus 12. That's my length times my width. And then I still need to multiply that to my height. How do I do that? Distribute again. So I'm going to distribute this piece. That would give me 24x to what power? Cubed, yes, 24x cubed. I need to distribute this one also. So I'm going to have plus 23x squared. Am I done with my distribution? What else do I need to distribute then? Negative 12. So this ends with what? Negative 12x or minus 12x. And that is my volume. Right. There are not any other like terms to combine together, so I'm going to leave it just like this. And we did end up with 3 terms at the end. Right. Do you guys have any questions about this bell work before we go and look at your reviews again? So I was going to start with number 8 on the review. If you need another copy of the review, please feel free to come up and grab one. Right. Yeah. 10 is almost exactly like what we just did on this bell work here. Like it is pretty much the exact same problem. We'll probably do a stopover at 9 first, and then we'll definitely get to 10 for sure to practice that one again. All right. On number 9, we have 2 parts here. Which one do you guys want to do first? Do part A? All right. I'll probably leave part B for you guys to do on your own since it's less work. And that way we'll hopefully get through more problems. So I see a couple things going on here in part A. No, you're fine. No, nobody's in the restroom right now. What are the operations that you see? Not the things inside the parentheses. Multiplication and. I see multiplication in between here. Exponent. Which one do I do first? Multiplication or exponents? Exponents. Do exponents first. All right, so what does an exponent of 2 mean? Multiply it by itself. So 3r plus 4 times another 3r plus 4. So let's go ahead and multiply those together. And then after we're done with that, we'll multiply by that third factor on the outside. So tell me what I need to distribute. 3r, I have to distribute it here to this 3r and to the 4. What's 3r times 3r? 9r squared. What's 3r times 4? 12r. Are we done distributing? No. What else do I need to distribute? The 4 needs to be distributed to both pieces. What is 4 times 3r? Another 12r. And then 4 times 4? 16. All right, so here's what I got from squaring. I'm going to bring this guy down because we haven't done anything with it yet. Inside those black parentheses, are there any like terms that I should combine together before I do anything else? 12r and 12r. What do I get when I put those two together? 24r. This is going to be a lot of distributing, isn't it? How many pieces are we going to need to distribute? 3 pieces to each part of my second polynomial, my binomial there. Sometimes people prefer to use something called an array or a box to help them with this distribution. I want to show you guys that in case it interests you. It's a helpful tool. So if you're going to use an array or an area model, since one side is a trinomial, I would take one side of my area model and split it into 3 pieces. And I'm going to put one term above each piece here. And then how many terms do I have in my other polynomial? 2. So I'd split it into 2 parts the other way. So 2r and -5. I think I'm going to write that in green so that it matches. And now I can make sure that I do all of the distributing that I need to by multiplying rows and columns together. So I'm looking here. The first thing I'm going to do is I'm going to multiply 2r with 9r squared, this row and this column where they meet. What do I get when I multiply those two together? 18r cubed. And then I move over. Oh, you're right. I wrote squared and you guys told me cubed. My apologies. Then I'm going to take this 2r and multiply it to the next column. So 2r and 24r. 48 r squared, yes. And then I want to take same row, so 2r, and I'm going to multiply it to the last column. So 2r and 16. 32r. So far, so good? So instead of having a whole bunch of arrows, I've put them in little boxes for me. Then I'm going to do this exact same thing with this -5 across the bottom. I'm going to multiply that to each of these pieces. -5 times 9r squared. -45 r squared. Then I take -5 and I multiply it to 24r. You might need to grab your calculators. -120r. And then the very last one, -5 times 16. -80. We're going to need to combine our like terms together, right? Where do you notice the like terms showing up when I arrange it like this? On my diagonals. These two are like terms, so I can combine those together. And these two are like terms. It makes it easier for me to combine my like terms here. So 18r cubed, it didn't have a like term. What do I get when I combine those two like terms together? 3r squared. So plus 3r squared. Then I have to combine these two together. -88, just -88, r. And to finish it off, -80. I'm going to leave part B for you guys to do on your own because that's just distributing two binomials. We've practiced that a couple times over. All right. Let's do number 9 and then we'll get to number 10. That's very similar to the bell work. What do you notice about the thing that we're supposed to be dividing by? About the smaller polynomial? This piece right here. How many terms does it have? One term. This is a monomial. When you have a monomial, you cannot use long or synthetic division. I'm going to rewrite this. Anything that I can write with that division sign, that's the line with two dots, I can rewrite that as a fraction. 81x to the 8th plus 36x to the 5th minus 27x squared would go up on top. What do I put on the bottom? 3x squared. When I write it like that, does anybody remember what I need to do with this now? Don't I have to bring down what? I did. It's right here. When I just have a monomial, one term on the bottom. Close. Very, very, very close. I'm thinking of a word that starts with D. And we're used to using this when I multiply things. Distribute. I'm going to distribute this division to each term. Since I'm just dividing it by one thing, I'm going to distribute here. And so I would have 81x to the 8th over 3x squared. I'm going to distribute it here. So I would have plus 36x to the 5th over 3x squared. Have I distributed to every term in my numerator? No, I have to distribute over here also. So minus 27x squared over 3x squared. Yes. I do this only with monomials. All right. Oh, yeah, that's supposed to be an 8, and I just wrote that just about as sloppy as I possibly could. Thank you, ma'am. There we go. And so then on each one of these, I want to simplify each fraction. So I'm going to look at the number part, and I'm going to divide that first. And then I'm going to look at the variable part, and I'll divide that second. So I'm looking at this piece to start with. Can I divide that in my calculator? What is 81 divided by 3? 27. And then I come over here and I look at the exponent part. X to the 8th divided by x squared. If I wrote this all out, I would have x multiplied by itself 8 times on the top and x multiplied by itself twice on the bottom. So what would happen? 2 of them would cancel. So I would end up with how many x's? 6. X to the 6th left over. I'm going to bring down my addition sign, and we're going to do the exact same thing to the next fraction. So I look at the numbers first. 36 divided by 3? 12. And then I look at the variable part. X to the 5th divided by x squared. This is going to be x to the, how much? 3rd. And if that's what you said, I apologize. I just couldn't hear. Bring down my subtraction. One more time. 27 divided by 3? 9. X squared divided by x squared. Just cancels out. Both of the x's on top would cancel with both of the x's on the bottom. So I would have this right here. Please, please, please make sure to take the time to look. If you have monomials, this is the only way to do it with monomials. And you only do it this way with monomials. So when there's no pluses or minuses in the thing that I am dividing by. All right, let's go look at number 10. We'll do 10 and 11, then we'll go back and look at 5. Number 5 was one of the ones that we did on Zoom on our virtual day. So we've gone over that one already, but I'll go back and look at that one again. Absolutely. All right. What do we want to find? The volume. And what do we say on the bell work? How do we find volume for things? Length times width times height. What is my length? 2x plus 5. So I'm going to have 2x plus 5 times my width. What's my width? 2x minus 5. And my height, 3x. This is how I will find the volume. How many pieces should we look at a time? Just 2. Let's just look at these 2 right here. So I'm going to take 2x plus 5, and I'm going to multiply it to 2x minus 5. What's the first things I need to multiply? 2x times 2x would give me 4x squared. What else should I multiply? 2x times negative 5. What is 2x times negative 5? Negative 10x. What else? 5 and 2x. What will that give me? Positive 10x. Anything else? 5 and negative 5, which will give me negative 25. All right, I'm going to pop parentheses around that. I'm going to bring down the 3x that we ignored. Are there any like terms that we should combine together? Negative 10x and positive 10x. What happens there? They're going to cancel out. So I'm actually going to bring my work around over here. So I have 4x squared minus 25 times 3x. What do I do from here? Distribute that 3x. So 4x squared times 3x would give me what? 12x cubed, because I have x squared times x. Anything else to distribute? Negative 25. So minus what? 75x. Here's my volume. Beautiful, beautiful, beautiful. Let's do 11, and then we'll go and look at number 5. And then if we have time, we'll come back and do 12. Although our bell work yesterday was just like number 12. All right. So on number 11, I'm going to use synthetic division to do this. So I'm going to need a number in this little box over here. What number should I put in that little box? Negative 7. And how did you get that again? Take x plus 7, set it equal to 0. So we would minus 7 from both sides. X equals negative 7. Perfect. So I'm going to put that in the box. And then what numbers do I put here? Yep, we start with 5. That's the coefficient on x to the 4th. And then I go to x to the 3rd. Negative 10, and then x squared. 3. And then x. Negative 4, and then my constant. 6. Draw my equal sign. Give it that little leg. I often like to break him off completely. And then what's my first step? Bring down the first number. So I'm bringing down the 5. Then what do I do? Multiply negative 7 times 5, negative 35. And what do I do with the negative 10 and negative 35? I add them together. What is negative 10 plus negative 35? Negative 45. Then what do I do? Multiply again. I need calculator help for this one. I can't do that one in my head. Negative 7 times negative 45. 315. That's big. I'm going to add it to the number up above. And get what? 300 and 18. Then what do? Multiply again. We're going to get an enormous number. What do I get when I multiply those? Negative 2,220. I got 26 when I did this, because you should have gotten 318. We're going to add that to the number up above. And so I get negative what? 2,230. Huge numbers here. Am I done? Do one more multiply right here. Negative times a negative, so I know I'm going to get a positive. Positive what? So negative 2230 times negative 7. Let me double check on my calculator here. 2230. Yeah, 15,610. And then I add that to the number up above, so 15,616. What do I call this piece at the end? That's the remainder. This will go over my denominator. All right, so let's write our final answer. That 5 right here, what do I put with that 5? Is that x to the 4th still? That's going to be x cubed. So 5x cubed. And then what? Minus 45x squared. And then plus 318x. Anything else? Minus 2,230. And then I have this remainder. Is the remainder positive or negative? Positive. So I'm going to put a plus. What was our remainder again? 15,616. It goes over my denominator. What were we dividing this all by? Not just negative 7. X plus 7. Beautiful. That's how I would write my final answer. I cannot take this any further for many reasons, not the least of which is I had a remainder. The only time I can take it further, like we did on the bell work yesterday, is when my remainder comes out to be a 0. Right. What'd you say? Then we can factor it further, yes. All right, number 5, the one with all the graphs on it. Let's go look at that one. And like I said, if we've got time, we'll come back and look at number 12. All right. What were the things that we were looking at here again? What part of the equation do I want to pay attention to? Yep, just the first term. I'm only going to look at the first term here, biggest exponent. There's a couple things that catch my eye here. First thing I'm going to pay attention to is this. That leading coefficient. Yes, ma'am. We did this on our virtual day, yes. Yep. What does that leading coefficient tell me? Which side does it tell me about? Right side. Always, always, always. Only tells you about the right side. What does this tell me the right side is doing? Right side goes down. All right, so which ones show a right side going down? D and C. How do I decide between them? This is where the degree comes in. What do you notice about that degree? It's odd. So what does that tell me about my ends? Ends are opposites. So which one, C or D? D. All right, let's go look at B. What's the only part of this whole equation I care about? First term here. And then once I know I'm looking at the first term, what do I look at first? Leading coefficient. What kind of a number is that? Positive. So what does that tell me? What's going up? Right side goes up. Always, only, ever tells me about the right side. Which of these graphs show the right side going up? A and B. How do I determine whether it's A or B? This is where this piece comes in. Because what do you notice about that number there? It's odd. And if it's odd, what does that tell me? Ends are opposites. So right side up with the ends going opposite ways would be which one? A. On equation C, what's the only part I care about looking at? First term. Which piece of the first term do I care about the most at the beginning? Coefficient. What does that leading coefficient tell me? Right side. And what's the right side doing? Up. So we said that was A and B. How do I know that it's not A again? The degree is even. And what happens in an even degree? Yep. Ends go the same direction. And so this is graph B. And the very last one over here, I look just at my first term. What does my leading coefficient tell me? Right side goes down. So how do I know that it has to be C and not D? Yes. Both sides are going down. We have an even degree here. And so that means the ends go the same way. So this would have to go with graph C. All right. I do not have time to do number 12. I will make sure that that is in one of the videos that I post today, probably fifth period, because fifth period is a little bit longer than all the others. So I should definitely have time to get to that one today in fifth period. I will post videos from this class period, fifth and sixth period. Sometimes listening to it explained in a slightly different way is really, really helpful. So you guys will have access to that. I will post all of the answers to every single question as well. That will be up probably around D-lunch today on our Canvas page. So how do you get to where the answers and the videos are going to be? Canvas. What do you go to after you're in Canvas? Modules. Go to this class, go to modules. Once you're in modules, what do you look for? Today's date. Look for today's date, the 10th, and click on that one. That's where the videos and the answer key will be. All right? For that, yes.